In this example problem, we are finding the limit as x approaches -5 of x plus 5 times the natural log of x plus 5 squared. So if we do a direct substitution with -5, notice that this is approaching -5 from the right side. And I just want to show you why that is, because if we draw the graph of the natural log of x plus 5, we're going to have an asymptote at x equal to -5, and it's going to look like this. So keeping that in mind, that means that when we do a direct substitution with this limit, we'll have 0 times -infinity. So we want to manipulate this so that we get an indeterminate form of 0 over 0 or infinity over infinity. So we're going to rewrite this as x approaches -5 from the right of the natural log of x plus 5 squared, and then we're going to put the x plus 5 in the denominator by writing it as 1 over x plus 5. And now when we do that, we have -infinity over 1 over 0, which is infinity, and now we have that indeterminate form of infinity over infinity. So we can apply L'Hopital's rule. To make this a little easier, I'm going to use some logarithmic rules here, and I'm going to drop down that 2 so that I have 2 natural log of x plus 5 over 1 over x plus 5. And actually, let's write this 1 over x plus 5 as x plus 5 to the -1 power, just making the derivative a little bit easier. So let's apply L'Hopital's rule, and we'll have the limit as x approaches -5 from the right. The derivative of natural log is 1 over the argument, so we'll have 2 times 1 over x plus 5. And then the chain rule, which is not really that necessary since the derivative of x plus 5 is 1. And then in the denominator, we'll drop down that -1, decrease the power by 1, and again with the chain rule, the derivative of x plus 5 is 1. So cleaning this up a little bit, I'm going to bring it up here. We have the limit as x approaches -5 from the right of 2 over x plus 5 over -1 over x plus 5 squared. We have complex fraction, so let's multiply by the reciprocal, and we'll have 2 over x plus 5 times x plus 5 squared over -1. And we can cancel one of these x plus 5s, and then we'll have the limit as x approaches -5 from the right of, let's write this as -2 times x plus 5. Now when we do a direct substitution, we'll have -2 times -5 plus 5, giving us -2 times 0, or 0.